Hello everyone, again this is the Cadete Enrico, and today I am going to solve for the sunset and sunrise and its amplitude. So let's get started. So now I have here the given. 1 December 2017 observes position latitude north 10 degrees 19 minutes and longitude east 123 degrees 53.0 minutes. Cebu City, or the zone description is known as +8 or ahead 8 hours of the GMT. So the problem is to calculate the sunrise and sunset, the sun's true bearing, and the time of sunrise and sunset using amplitude table. So first we need to calculate the sunrise. So I have here the steps. Step 1, interpolate the corresponding latitude data to look for the time of the sunrise when the latitude is north 10 degrees and 19 minutes, which is here. So first, we need to go to our nautical almanac or nautical pages. So I have here the value of 10 degrees of latitude, but we need to interpolate because the true value of our latitude is north 10 degrees and 19 minutes, but the value here in the pages is only 20 degrees and 10 minutes. So the value for 10 degrees, this is how to interpolate the value of the latitude. So the value of 10 degrees is 06 hours, which is here, 06 hours and 02 minutes. And the value of the upper value is 20 degrees, which has the equivalent time of sunrise at 06 hours 19 minutes and 19 minutes. So this value here, this is the value that we are looking for, which is the latitude of 10 degrees and 19 minutes. So subtract it from 20 degrees. So we have the result here of 9 degrees and 41 minutes. So get our calculator. So 20 degrees is subtracted to 10 degrees 19.0 minutes. So we have here the value of 9 degrees and 41 minutes. So, and the next step is to subtract these two value, 20 degrees to 10 degrees. So 20 degrees basically subtracted to 10 degrees, which resulted to 10 degrees. So to get the value, we need to interpolate. We need to look for the value of the time also. So the value of the time or the sunrise time of 10 degrees and 19 minutes is unknown. That is why we put X in here. But the value, we know the value of 20 degrees and 10 degrees, which is 20 degrees, 06 hours and 19 minutes, and 10 degrees is 06 hours, 02 minutes. So we put question mark here, so because we need to find this value. So this is how to interpolate or to calculate. So we have here 06 hours 19 minutes. We need to subtract because the value of our sunrise time is decreasing. So basically the value of this latitude is decreasing. So we need to subtract the value of 20 degrees to the result of this equation here. So 17 minutes is the difference between the value of time from 20 degrees to 10 degrees, and multiply it to the difference between 20 degrees and 10 degrees 19 minutes, which has 9 degrees and 41 minutes, over the value of the difference between 20 degrees and 10 degrees, which is 10 degrees. So to calculate this, we need to first operate this 9 degrees 41 minutes divided to 10 degrees, which result to 0.968, and so on and so forth, multiplied to the value of the difference between the hour of time of 20 degrees and 10 minutes, which is 17 minutes. So we have here the result of 16 degrees 27 16 degrees and 27 minutes. And we will now subtract this to the value of the upper value of 20 degrees. So 06 hours and 19 minutes subtracted to the result of this equation here, which is 00 hours 16 minutes 28 seconds. So we have the result of 06 hours 2 minutes and 32 seconds. This will be now the value of the almanac sunrise time. So this is now the interpolated value. So I have written it here, 06 hours 2 minutes and 32 seconds. The second step is convert the longitude to time using the conversion table of the time to arc. So we need to go to the conversion table, which is here. This is the conversion table of arc to time. So our longitude is east 123 degrees. So the equivalent value of this is, we need to look for 123 degrees, which is here. So the equivalent value of this is 8 hours and 12 minutes. So this is the value of the converted longitude. And now we still need to look for the 53 minutes. So we need to look for here in minutes. So look for 53 since it is 53 minutes, and the equivalent value is 3 minutes and 32 seconds. Now we need to add this time. So 08 hours 12 minutes added to 00 hours 03 minutes and 32 seconds. So you have here the result of 08 hours 15 minutes and 32 seconds. Now for the step 3, find the local time. So in order for us to find the local time, since this is the value of our almanac sunrise, which is here, almanac sunrise, and the value of our longitude in time, we need to subtract these two values. So to subtract it, 08 hours 15 minutes 32 seconds subtracted to 06 hours 02 minutes 32 seconds, we have arrived at this value of 02 hours and 13 minutes. Now, to get the local time, we need to subtract this value to 24 hours and 00 minutes. So 24 hours and 00 minutes subtracted to 02 hours and 13 minutes, which resulted to 21 degrees 47 minutes on November 30. So to get the local time, we need to apply the zone description, which is +8. So we will add this 08 hours. So we have resulted to 29 hours and 47 minutes. And now we will subtract it to 24 hours. 24 hours. So the local time of the sunrise is 5 hours 47 minutes and 00 seconds on December 1. So this is how it goes. So we calculated the GMT, which is here, and added the value of from the zone description from the Philippines. So resulted to the local time of 5 hours 47 minutes and 00 seconds. This is now the sunrise of in Cebu, Philippines. So next, we need to calculate also the sunset. So solution, repeat the same procedure. So the first procedure is interpolate the corresponding latitude data to look for the time of sunrise when the latitude is, so same latitude, and we need to again convert this value again to our time. So now we need to interpolate the value of the latitude. So since we are looking for the sunset, we will look over this area of our almanac. So this is the sunset and this is the sunrise. So for sunset, we have here. So the latitude is north 10 degrees 19 minutes. So again, since we don't have the value of this, so we need to interpolate, and we have the upper value of 20 degrees and the equivalent time of 20 degrees is 17 minutes and 17 hours and 19 minutes. And we have the lower value, which is the 10 degrees, and the equivalent time is 17 hours and 37 minutes, which is here. So to find the value of the 10 degrees and 19 minutes, we need to subtract the upper value to the lower value. So we resulted to 9 degrees again and 14 minutes, and same procedure from 20 degrees to 10 degrees subtracted is equals to 10 degrees. So in order for us to locate the time of this, so we will put x here since it is the unknown, and we will subtract this upper value to the lower value, which is 18 minutes. So this is how to interpolate it. Since 17 hours 19 minutes, we will add this value to find this value, because our sunset time is increasing. So we will add, that is why we have this operation as addition. And we will operate this 18 minutes came from this, the difference of the equivalent time of 20 degrees and 10 minutes. And this 9 degrees and 14 minutes came from here, and 10 degrees is here. So first, to interpolate this, we need to get our calculator and equate this. So 9 degrees, 14 minutes, divided to 10 degrees and 10 degrees. So we have here the value of 0.92 multiplied to the value of 18 minutes. So that is why we have here 16 minutes and 37 seconds. So we will add this to this value to get the value of north 10 degrees and 19 minutes. Plus, so 17 hours plus 19 minutes plus 00 hours 16 minutes 37 seconds. So we have here the value of the sunset in the almanac, or the interpolated value from the almanac in sunset is 17 hours and 33 minutes. Now, to get the GMT, we have here the value of the almanac, the 17 hours, 33 minutes, and 37 seconds. And here also is the converted longitude time, so which is 08 hours 15 minutes and 32 seconds. I have converted it earlier, so that is why I wrote it here. We will name it west because it is in sunset. So because the sunrise is east and the sunset will be west. So we will subtract this two value, 17 hours 33 minutes, 17 hours 33 minutes 37 seconds subtracted to the longitude in time, which is 08 hours 15 minutes 32 seconds. We resulted to the time of 09 hours 18 minutes and 5 seconds. Now to get the local time, we will apply the zone description. So since this is the GMT and our zone description is +8, so we will add 8 hours because the zone description is 8 hours ahead from the GMT. So 09 hours 18 minutes 5 seconds added to 08 hours. That is why we resulted to this value, which is 17 hours 18 minutes and 5 seconds. This is the value of the local time, or the time of sunset in local time, and the time of sunset in GMT time, and the time of sunset in almanac. So now we need to find the true bearing of the sunrise and sunset using the latitude and using the amplitude table. So we need the latitude, which is north 10 degrees and 19 minutes. So in order for us to find the declination, we need to base from the time of the sunrise, which is 5 hours. So we will look for 5 hours in December 1. So 5 hours in December 1, we have south 21 degrees and 49.4 minutes. So in order for us to locate the sunrise true bearing, we need to go to the amplitude table and look for the value of the intersection of north 10 degrees and south 21 degrees. So this is the latitude 10 degrees and declination of 21 degrees south. So we have here the value of 21.4 degrees. So that is why we have here 22.4 degrees. 22.4 degrees. So added to 90 degrees because it is in southeast hemisphere. So in order for us to get the true bearing, we need to add 90 degrees. This is based on the longitude. The prefix is based on the longitude and the suffix is based on the declination. So we have here this value and we will get our calculator. 22 degrees 0.4 minutes added to 90 degrees. So we have here the true bearings of sunrise is 112 degrees 0.4 112 degrees 112.4 degrees true. So for us again to calculate the sunrise bearing also, we need again the latitude and the declination. To get the declination, we need to base the time from our sunset, which is 17. We have solved it earlier, which is 17 hours. So we need to locate for the 17 hours here. So this is the value of 17 hours. So south 21 degrees 54.0 minutes. So now I have here the value of the declination. So to get the sunset bearing, we need to go to again our amplitude table. To locate for our amplitude value, we have the latitude, which is 10 degrees 10 degrees, and again the value of our declination, which is 21.23 degrees added to 180. Now we have here the prefix west and the suffix south because we know that the sunset will be on the west and the sunrise will be on the east. So this is based on the longitude, and this is the suffix is based on the latitude. I mean based on the declination. So we will add 180 because it is in southwest hemisphere. So 21 degrees 21.3 degrees 21.23 degrees added to 180 degrees. That is why we have this value of 201 degrees 0.27 true. So that is how to solve the sunset and sunrise and to find the true bearing of the sunset and sunrise using the amplitude table. So again, this is Tech Cadet Enrico. Thank you and God bless.